All right, so continuing on with logarithmic equations from the last video, we did number 2. Now I want to try number 3. So number 3, it gives us log base 2 of 5 plus 2x minus log base 2 of 4 minus x equals 3. So with this equation, we have two logarithmic expressions. They both have base 2, right? The base is always going to be that small number below the g. So both of these have base 2, and if they both have the same base, then we can write them as one expression. We're going to be using the quotient rule. The quotient rule for logarithms. So what the quotient rule says is if you have two expressions and they have the same base, but they have different things in parentheses, let's just put these in parentheses. And if you have subtraction in the middle, then you can change that subtraction to division. So on the inside of the parentheses, you'll have x divided by y. So notice the base didn't change. What changed is on the inside of the parentheses, where we had x minus y, now we have x divided by y. So that's the quotient rule. So we're going to take this and we're going to write it as one logarithm. We know that in this equation, it has a base of 2. And we're going to put 5 plus 2x on top. And we're going to put 4 minus x in the bottom. And then we close it up. So this is going to be equal to 3 on the other side. So now I've got one logarithm. And now I can take both sides to a base of 2. So the first one, I'm going to have a base of 2. I put the left side as the new exponent. That's going to be log base 2 of this fraction right here. And it's going to be equal to a base of 2 with an exponent of 3. So now what that does is, on the left side, the 2's are going to cancel out because they're both bases, right? The 2 is the base for the exponential expression, and 2 is the base for the logarithmic expression. Therefore, they cancel each other out. And whatever's on the inside of the parentheses is going to come down. 5 plus 2x over 4 minus x. And then over here on the right side, I have 2 to the third power, and that's going to give me 8. So what we're going to do with this is we're going to solve it for x. We're going to see if we can get x by itself on one side, and we get a rational equation because this right here is a rational expression. A rational expression. I'll just write EXP. Okay, so on the next slide, we'll do 5 plus 2x over 4 minus x is equal to 8. And we will solve this rational equation. So what I could do is I could multiply both sides by what's in the denominator. That way, I can get rid of the bottom of the fraction. So what happens is, if I multiply both sides by 4 minus x, then the 4 minus x on the top is going to cancel out with the 4 minus x on the bottom. And that leaves me with just 5 plus 2x at the top. So I bring that down. 5 plus 2x. On the other side, I can take that 8 that's on the outside and I can multiply it by everything on the inside. When I do 8 times 4, I'm going to get 32. And when I do 8 times x, I'm going to get 8x. So now I have 5 plus 2x equals 32 minus 8x. I want to get all the x's to one side first, so I'm going to add 8x to both sides. That way, they'll cancel out on the right side, and on the left side, I'll have 5 plus 10x. So I add up the like terms on the left side. 8x plus 2x will give us 10x. So now, to get rid of that 5, I need to subtract it from both sides, because the 5 is positive, and I can get rid of it by subtracting 5. So those cancel out, and I'm left with 10x is equal to 32 minus 5. That would just be 27. And then I can divide both sides by 10. So what that'll do is that'll get rid of the 10s that are on the left side. So then my answer is going to be x equals 27 over 10. That would be the fraction, but if you wanted to write it as a decimal, you would just be dividing by 10, so it would be 2.7. So I'll put 27 over 10 inside the solution set.